So now we are going to move to the second problem, which is the Laplace transform of e to the power of at. So let us do this. So let us therefore calculate the Laplace transform of e to the power of at, where a is taken as a complex quantity. So let us therefore substitute into the integral and we will get the answer. So let us therefore do this. So the Laplace transform of e to the power of at is, you substitute here, f of t is e to the power of at. Then you have e to the power of minus st, s minus a, right? So I will write s minus a. Then you have a dt. S is a complex parameter. Already you know that S is a complex parameter. Now we are also assuming that A is a complex parameter. So therefore let us write down explicitly x plus iy minus A is alpha plus I beta, and that's all. Like this you can write, which is nothing but this is x minus alpha y minus beta multiplied by dt. We will do the integration only after the Cauchy criterion. The Cauchy criterion is the absolute value of the quantity under integral. That means let me write down this absolute value. This quantity is e to the power of minus t into x minus alpha. I'll write down like that, x minus alpha. There's I here, so I'll write down e to the power of, all that should go to 0 as t tends to infinity. That is the Cauchy criterion. And this I, so when you do 2 to 3 problems, whenever you get e to the power of I, there is no need to write this because this quantity is 1. So you can actually avoid one more step here. This quantity is 1 here. So what is left out is only this quantity. And for this quantity also, absolute value is not required because it is already a positive number. So therefore, essentially it means that we have e to the power of minus t into x minus alpha should approach 0 as t approaches infinity. So from here I will write down here. So this quantity will go to 0 provided x minus alpha is positive. So if this is positive, then t is already positive, then only this negative will survive. What I mean to saying that negative will survive is minus of minus will become plus. So this quantity should not be negative. If this is negative, this minus will become plus. Therefore, we demand that x minus alpha should be positive. That's the meaning of this. So from here I will write down here. So that is x minus alpha should be positive. Positive means greater than 0. So what does it mean? So this means that we want x greater than alpha is the condition. What does this mean? You should not write x and alpha. We should always say that this is the real part of S greater than real part of A. So that means we have not done still the integration, but even before doing the integration, we are now discovering the region of convergence. So provided that the real part of S is greater than real part of A, you can proceed further to simplify the integration. Okay. If you are unable to discover the region of convergence, then there is no point in evaluating the integral. So you are wasting your time, and also finally even if you evaluate, that result is totally invalid result. So therefore we don't want to do the integration before discovering the ROC. So first let us discover the ROC, then if it is successful, after that you can evaluate the integral. Okay, so now that ROC is now discovered, this solves you 50% of the problem. The remaining 50% of the problem is actually doing the integration. So this integral, we have not finished doing the integration. Okay, so let us therefore evaluate the integral I here. So now we can continue this I here. So the integral is of course easy to evaluate. The integral is equal to, in the limit of r tends to infinity, you have an integral 0 to r, then you have e to the power of, so which is nothing but in the limit of r tends to infinity, let us do the integration, which is nothing but e to the power of minus of s minus a 0 r. So you can substitute t equal to r and t equal to 0, 1 divided by s minus a. So therefore our conclusion is this. So what we write is, so we will say that Laplace transform of, conclusion is that Laplace transform of e to the power of at is given by 1 by s minus a if condition is there, this one, if real part of, so as I already told you, This result 1 divided by s minus a is the result of simplifying the integration. This will come if you simplify the integral. This will come if you work out with the Cauchy criterion. So integration is 50% of the job. The remaining 50% of the job is this one, and then you have to put the merging that's if condition. You can always ask the question, suppose if the if condition is fails, if the real part is not greater than, what will happen means this expression is totally invalid, and then we say that Laplace transform does not exist in that region. You can always draw the diagram. So that is 0. Then you have 1, 2, 3, etc. and some a is there here. Okay. So 1, 2, 3, etc. a, and then you have a lot of numbers here. So that is this portion is the real part of s. And this side will be the imaginary part of s. So for the a, what you do is you put this line like that. Because real part of a is there. A is a complex number, right? So a is a complex number, which means that we can say that it is alpha plus I beta. So this is supposed to be alpha here. Actually, this is alpha plus I beta. Alpha is on this side, beta will be on the y-axis. So that is alpha comma beta. So now we can put the shaded region. Everything on the right side to the line A. And as usual, you have to know, you should not touch this line here. So I am just erasing, because this is greater than A, it is not greater than or equal to A. Equal to is not there. So this, the shading should not touch this vertical line. So that is, you have to be careful. Then what happens is, in this particular shaded region, so the Laplace transform of e to the power of at would exist here. And here what happens is, Laplace transform of e to the power of at does not exist. So all the way which is unshaded region does not exist, here it is exist. So that's all. So this is how you have to do. So you do this integration, you do the Cauchy condition, you draw the region of convergence, and that completes the information. And okay, so similarly you can also do for the Laplace transform of cos omega t, but that probably I will do in the next class along with another example where maybe we can demonstrate a particular situation in which you cannot do the integration. Okay, because you are able to do this successfully integration, you got this answer. Suppose if you are unable to get the answer, unable to do the integration, then there is the Laplace transform does not exist. So for that also I want to give an example that we will do in another class. Okay.